Welcome everyone. Thanks for joining our webinar about climate impacts. We are Leadership and Sustainability, a company focusing on sustainability services in the consumer goods sector. My name is Karin Ekberg, and I'm the CEO and founder of Leadership and Sustainability. Since we started 8 years ago, we have grown to a team of more than 50 experts worldwide. We are present in many countries such as Germany, Bangladesh, Bulgaria, China, Egypt, India, Indonesia, Pakistan, Portugal, Romania, Tunisia, Turkey, and Vietnam. And our two main streams of services are related to strategy, reporting, footprinting, and greenhouse gas services on the one hand, and supply chain services and audits on the other hand. Today I'm joined by my colleagues Janne Tesch and Sophia Wolf, and the three of us are happy to take you through our webinar today. And you will hear more from Janne and Sophia a bit later. Let me give you an overview of our agenda today. We are already underway with the welcome and introduction. In today's session, we will start with looking at climate impacts of the textile industry. And then we will talk about 3 climate tools, namely the carbon footprinting, science-based targets, as well as greenhouse gas verification. And towards the end of the webinar, we will have time to discuss any questions you might have. We will send out this slide deck after the webinar and we'll also record the session. You are all muted in order to ensure good audio quality. And if you have questions, you can send them via the Q&A box. So please do not use the chat function. Please use the Q&A box. So let me now briefly talk about climate impacts of the textile industry. Climate-related risks to health, livelihoods, food security, water supply, human security, and economic growth are projected to increase with global warming of 1.5 degrees and increase even further with the global warming towards 2 degrees. In order to minimize global warming, it is crucial to minimize greenhouse gas emissions. And some of the impacts are listed here. Health issues, loss of livelihoods, loss of biodiversity, and desertification are a few of the many different impacts we see because of global warming. Thus, every bit of warming makes a difference, and so do our actions. And to make a difference with our actions, we need to understand what our actions cause in the first step. Now we'll talk about the overall impact of the textile sector on global greenhouse gas emissions. According to a McKinsey study, the emissions from the textile sector contribute to 4% of global emissions. These emissions are as high as countrywide emissions of France, Germany, and UK. This number is an estimation, so the actual contribution might even be higher. And another important aspect is that 70% of all textile sector emissions are caused by upstream activities, thus in the manufacturing phase of the products. Now that we have understood the importance of taking climate risks and climate impacts as seriously, let us take a look at different climate tools that are relevant to understand your own climate impacts as a supplier or as a brand. First, we will have a look at carbon footprinting. Let us start with the definition of carbon footprinting. The carbon footprint is a measure of the exclusive total amount of carbon dioxide greenhouse gas emissions that is directly and indirectly caused by an activity or is accumulated over all life stages of a product. And let us briefly look at the greenhouse gas protocol accounting principles that are relevant for carbon footprint, since the greenhouse gas protocol is really the mandatory document when you want to calculate a carbon footprint. We have the principles relevance ensures that the carbon footprint is calculated suitably, or the calculation is suitably reflects the greenhouse gas emissions of the company and serves the decision-making needs. Completeness secures the reporting on all greenhouse gas emission sources and activities within the chosen inventory boundary. Consistency assures the consistent use of methodologies to allow for valuable comparisons of emissions over time. And transparency facilitates addressing all relevant issues in a factual and conclusive manner. And finally, accuracy ensures that uncertainties are reduced as far as practicable. As you may know, the Greenhouse Gas Protocol Standard classifies the company's greenhouse gas emissions into 3 scopes, and you see them all here. Scope 1. These are direct emissions from owned and controlled sources. So, for example, if you have a factory, you have a boiler on site, and you burn fuel in that boiler, then the emissions that are generated when burning that oil, for example, or gas in the boiler, these emissions are called Scope 1 emissions. Scope 2 emissions, these are indirect emissions. This is energy you use on site, but the emissions when generating that energy are not produced on site. This can be if you buy electricity, for example. The electricity is generated outside your own site, so the emissions are outside of your site, but they are there because you buy the electricity. The same is true, for example, for steam or for hot water. And so these are Scope 2, the indirect emissions. And finally, we have Scope 3. Those are also direct emissions, but not included in Scope 2, that occur in the value chain of the reporting company. So both upstream and downstream emissions. And you can see on this slide here we have Scope 3 upstreams, and downstream we also have Scope 3 emissions. And as you can see here, there are many different categories within the Scope 3 emissions. So it's quite complex. And if you want to calculate your Scope 3 emissions, you would need to go really far upstreams into your supply chain. So you see, for example, our purchased goods and services, capital goods, transportation and distribution, business travel. These are all upstream Scope 3 emissions. And on the downstream side, we again have transportation. We have processing of sold products. We have use of the products and end-of-life treatment of the products as well, among other categories. So there are lots of different categories that you need to get hold of if you want to calculate your Scope 3 emissions. The data collection, when collecting data for the carbon footprint calculations, there are 2 main types of data. We have primary data and we have secondary data. Primary data is information collected directly from suppliers or from your own brand activities or value chain partners. And these are then related to specific activities. So, for example, if you know exactly how much electricity you are using and where you are buying your electricity, they can tell you which emissions they have linked to this electricity that you buy. Then this is primary data. Or if you know how much oil you are burning every year, then this is also primary data, because you can calculate, you have a greenhouse gas factor that you can, so that you can calculate the greenhouse gas emissions from your oil that you are burning on site. This is all primary data. So this data is often more specific and also more accurate than secondary data. On the other hand, secondary data is industry average data or generic proxy data that may be used if the primary data is not available or if it's not practical to collect primary data. So this can include data from industry associations, from government agencies, from academic research, or from other publications that you can get hold of. So it's also important to note that using secondary data can lead to errors and inaccuracies in carbon footprint calculations. And remember, one of the principles is actually accuracy. And so therefore, you may not have the reliability in the results the way you would have if you would be using only primary data. So therefore, primary data should be used as far as possible. And now, let me just also explain the very basic calculation method of greenhouse gas emission. So the basic calculation method, it works as follows. You have an activity data that is multiplied with an emission factor and then also multiplied with the global warming potential of this emission factor, so that the sum shows the carbon dioxide equivalence. Because we have many different greenhouse gas emissions, not only carbon dioxide is a greenhouse gas, but also, for example, methane is one, and they all have different global warming potential. So some other greenhouse gases, they may be more potent than what carbon dioxide is, for example. So, and then we have the activity data, which represent, for example, the liters of fuel consumed, the kilograms of material consumed, or the square meters of area occupied. And then you have the emission factor that represents the emissions per unit. And finally, you have your global warming potential, which is used then to convert all numbers down to carbon dioxide equivalences in order to establish comparability. So, for example, CO2 has a global warming potential of 1 at 100 years. Methane has a global warming potential of 21. So methane is 21 times higher when it comes to the potency of the emissions. And in the end, you then receive or generate and calculate the CO2 equivalent of emissions. So this is the very, very simple and basic calculation that you have to do. And of course, the challenge may be to find the activity data, as I already mentioned. The challenge may also be to find the right and the correct emission factors. It's not always so easy to decide which emission factor that you should be using. There are lots of different sources around. You need to be able to analyze these sources and apply the correct emission factors for your case. And the global warming potential is not so difficult. These are all listed, for example, in the IPCC reports. And finally, you then have the result of your CO2 equivalent emissions. And now regarding tools, softwares, etc. So of course, in order to simplify the process of calculating a carbon footprint, calculation tools or a software can be really useful. There exists a variety of tools, but most of them are not really specific for textiles. Some of the available tools are very simple, but with a high workload for data collection, compilation, and preparation. And in addition, often the tools may not be totally transparent. And there are also other more sophisticated reporting and management tools that are offered in the form of software as a service, which provide customized solutions for every need, including automatic data collection and the creation of various standardized reports, for example. So careful consideration is always necessary when deciding whether or not to purchase and use software in the calculation. So very often it might even be helpful to do your first calculations even manually. Because even if you want to use a software, it probably would need to be customized for your needs exactly. And if you haven't done your calculation yet, the steps might not be clearly outlined yet. And you might have other data that you don't have available just yet. And so now about what do you do? Once you have your carbon footprint, what do you do about it? Of course, you want to reduce your carbon footprint. Many of you might already have defined a science-based target, or your brands that are buying from you have defined a science-based target and are now asking you to also reduce your carbon footprint. And so what do you do about that? Well, first of all, and I think this is the most important one, that is to implement energy efficiency measures. So because this way you actually reduce your energy consumption. And that is the most important one, because even if you use, let's say, renewable energy, you still have a certain energy consumption. But the more you can reduce your energy consumption from the beginning, the lesser, of course, also not only your consumption, but also your greenhouse gas emissions will be, whatever type of fuel or renewable energy you use. And then you can look for renewable energy sources. You can also look to reduce your employee carbon footprint. You can engage with your suppliers and see which other sustainable practices your suppliers can implement. Or if you are a supplier and a factory, there are probably lots of things you can do in your factory to even reduce your energy consumption. And then even waste reduction might lead to a reduced energy consumption. Meeting technologies, we all know, we have all started to work much more virtually than we used to do a few years ago. So that has, of course, also a positive effect, as has also if you reduce business travel. And of course, reducing business travel has a significant impact on greenhouse gas emissions as well. And then, of course, you need to also monitor your progress and make sure that you always have a very clear action plan and that you adjust your action plan as you go and as needed. So what is important here? To set smart targets, to be really clear about your targets. They should be measurable, and you should be able to follow up on them. You should have someone who is responsible for them. You should have milestones, and you should follow up on a regular basis. It doesn't make sense to say, okay, I want to reduce 3% this year, and then you leave it and come back in a year from now, because then you probably will not have reached your target. And you know, we see a lot of factories that have targets, but very often the plans are not so clear. So you need a really clear implementation plan where you technically have investigated how am I actually going to reduce my carbon footprint. So that is that. And then, of course, you should have someone responsible, and you should have a clear reduction timeline. And with that, if your company is looking for support in order to calculate and understand your climate impacts, we at Leadership and Sustainability can offer suitable projects. For instance, we could start with calculating your Scope 1 and 2 emissions, but we can also calculate your Scope 3 emissions. And if you're curious about how such a project looks like, feel free to contact us. And with that, I would like to hand over now to Sophia, who will give you an overview about science-based targets.
Yes, exactly. Thank you, Karin, for this overview of the process of carbon footprinting. And now I would like to continue with the process of setting science-based targets. Once you have calculated your company's carbon footprint and have developed a mitigation plan, the next step in the process is to set science-based targets. Science-based targets are emission reduction goals that are aligned with the latest climate science and provide companies with a roadmap to future-proof growth. And they specify not only the amount, but also the speed at which companies must reduce their greenhouse gas emissions. And these targets are considered science-based when they align with objectives of the Paris Agreement, which contains the goal of limiting global warming to well below 2 degrees Celsius above pre-industrial levels, and to pursue efforts to limit global warming to 1.5 degrees Celsius. So embracing science-based targets is therefore not just a commitment to environmental responsibility, but also a strategic imperative for a sustainable future. So science-based targets are instrumental in driving the transition to a low-carbon future, and they provide a structured framework for organizations to reduce their carbon footprint and to contribute to a more sustainable world. To trace carbon footprint performance over time, there are generally 4 key steps to do. The first step is to establish a baseline. And this is done by selecting a base year and determining your organization's emissions during this specific year. And this baseline year serves as a reference point for measuring progress, and it's also essential to have a clear understanding of your starting point for the following steps. And in the second step, the reduction goals are set. Specific reduction goals for Scope 1, Scope 2, and Scope 3 are determined, and these goals should align with your organization's commitment to reducing your carbon footprint. In step 3, the baseline is recalculated if necessary, and in some cases it might be necessary to recalculate it. Maybe there have been changes in your business operations, or if you discover data inaccuracies in your initial calculation, then it might be important to recalculate your baseline emissions. Then in step 4, the emissions and reductions over time are monitored. And it's necessary to continuously track and account for your emissions and also for the reductions as you implement climate strategies and initiatives to meet your science-based targets. So regular reporting and monitoring are essential for staying on course and making any necessary adjustments to achieve your sustainability objectives. And all in all, these 4 steps provide a systematic approach for organizations to assess and improve their carbon footprint. And with these 4 steps, it's possible to contribute to a more sustainable future. Now let's have a look how to set science-based targets. In general, there are 2 different targets that can be set. The first option is to set absolute targets. An absolute target refers to the goal of reducing greenhouse gas emissions into the atmosphere over time, typically measured in units of metric tons of CO2 equivalent. And this type of target focuses on achieving a direct reduction in the total emission of your organization, and it's a straightforward approach, where the aim is to lower the overall environmental impact by reducing the actual emissions, regardless of the changes in other factors like revenue or production levels. And this approach provides a clear and quantifiable measure of your organization's commitment to reducing its carbon footprint. Then secondly, we have the option to set intensity targets. And an intensity target focuses on reducing the ratio of greenhouse gas emissions relative to a specific business metric, such as the output or the revenue, sales or production. And instead of aiming to reduce absolute emissions, like in the case of the absolute target, an intensity target looks at how efficiently emissions are produced concerning a particular business activity or output. And now we have 2 examples for an absolute and also for an intensity target. With an absolute target, the aim could be, for example, to reduce the total scope 3 emissions by 10% from the levels in 2020 by the year 2025. And with an intensity target, the objective is to, for example, lower the scope 3 emissions per unit of revenue by 25% compared to the levels in 2020 by 2025. And as you just see from these examples, it's necessary to determine a baseline year and also a target year for setting your science-based targets. So when selecting a baseline year, it's essential to choose a year that accurately represents your company's typical operations and environmental performance. This means avoiding years with exceptional circumstances, such as significant mergers or other one-time events that could distort the whole data, or like a COVID year, something like that. And you should also ensure that you have access to reliable and verifiable data for all scopes. So accurate historical data is crucial for this whole scenario planning. And it also serves as a foundation for setting meaningful climate targets and tracking progress. Additionally, the baseline year should be representative of the company's typical GHG profile. And finally, selecting a baseline year that allows for forward-looking ambition. And this offers a good starting point from which you can make meaningful reductions. Then secondly, it's important to set a target year, and setting a minimum of 5 years and a maximum of 10 years for achieving emission reduction targets is a recommended approach. And it's recommended to formulate both long-term and near-term milestones. The long-term targets with net zero emissions as the ultimate aim by 2040 or 2050 emphasize a commitment to mitigating climate risks and embracing opportunities. And the overarching goal of limiting global temperature increase to 1.5 degrees Celsius is crucial. It's a more ambitious target than the 2 degrees Celsius rise, and by aspiring to stay within that 1.5 degrees Celsius threshold, organizations demonstrate their dedication to safeguarding our planet's future. Yeah, thank you for listening to this part of our webinar today. I will now hand over to my dear colleague Janne for getting some more insights into GHG verification.
Thank you, Sophia. Yes, so I would like to cover greenhouse gas verifications as a topic, and obviously this step comes once you have calculated your carbon footprint. Greenhouse gas verifications are an independent assurance tool. A verifier reviews your whole carbon footprint inventory. On the one hand, an official third-party assurance of your carbon footprint will increase credibility towards stakeholders. And on the other hand, it is a great approach to gain an external perspective on your calculations. You will learn from the process, and you will be able to identify gaps and improvement opportunities. On this slide, I would like to briefly give you an idea of the methodology and process of greenhouse gas verification. In the kickoff meeting, we get to know each other, we agree on the project timeline, and also discuss first questions about your calculated carbon footprint. After the kickoff meeting, we need to receive the whole greenhouse gas documentation in order to be able to verify the carbon footprint. After the provision of these documents, the verifier will scan these in order to request any additional information needed. And then the actual verification process can take place. A verification of a carbon footprint contains, for example, the recalculation of sample emissions, sample checkups of emission factors, and the identification of any uncertainties or mistakes. After roundabout the first half of verification, the verifier interviews the person responsible for calculating the carbon footprint in order to clarify any open topics and to discuss just the calculation process behind the carbon footprint. This is an ongoing process and is helpful also for the verified party to understand any mistakes or improvement opportunities. And then eventually, in a closing meeting, the verification process will be summarized and there will be time for mutual feedback. In the end, if verified and corrected, obviously, an official independent third-party assurance statement will be handed over, which can then be communicated publicly. So that shows in the end, again, once you went through the whole greenhouse gas verification process, on the one hand, you have this assurance statement, which gives you more credibility towards your stakeholders. And throughout the verification process, you will learn a lot through the external perspective. Yes, and with that, I would like to hand back to Karin, who will now lead the discussion.
Okay, thank you so much, Janne, and thank you, Sophia, for this presentation. And now we will open up for your questions. So please send your questions in the Q&A box, and we will seek to respond to them. And so we have one question here. Is it possible to see an example greenhouse gas computation of end of life of apparels, textiles? No, we don't have that available right now. So we could not respond to that right now. There are different studies available. We can make perhaps one study available to you after the webinar. And then we have the question here, reduction of energy consumption or increasing energy efficiency, which approach is better? Well, I think this is basically the same thing. If you use your energy more efficient, then you will also reduce your energy consumption. So I don't see a big difference there. And then can you advise upstream transportation and distribution, including what activities in a garment factory? Well, these would be all transportation activities that takes place upstream of your factory. So all the transportation throughout the entire supply chain upstreams would be included in this category. So not only the transportation of goods, or let's say fabrics, for example, or raw materials coming into your factory, but also the preceding steps. Can the baseline be chosen as a comparative study of a few significant years? If so, is it mandatory to take the same approach while recalculating baseline? Well, as far as I know, according to the Science-Based Target initiative, you do need to select one baseline year. So you need to take 1 year, and you would not be able to take several years and then make like an average. I think that would also be very, very difficult to compare with. So no is the right answer for that one. If it is possible to change your baseline year after publishing your science-based target goal, there is a process for doing so. It's a bit complicated, and then you would need to go and look up that in the Science-Based Target Initiative and the protocols. Do you conduct any training programs for all of these, if any individual want to enroll? Yes, we do. So please let us know, and we can see what training programs would be appropriate for you to do. And then the next question, third part, is that make verifications are auditing companies. Yeah, you can call them auditing companies as well. That's true. What would be the added value of the greenhouse gas verification when a carbon footprint is calculated according to the principles of the greenhouse gas protocol? Well, this is the added value is really the 4I principle, that you have someone externally who is trained to review and to assure calculations that have had a look at your own calculations. So it is an added safety measure, so to say. But also there are many requirements related to communication, for example, and with the new upcoming reporting directives that actually ask you to verify your own calculations before you publish them. There is a question also here, how to measure energy efficiency. And yes, I mean, it is really based, it depends on what you are really working at. So you can, for example, say I have a certain energy consumption with a certain process right now, and I change the process so that I reduce the energy, and then you can calculate. Let's say you have, after the changes, you are only using 95% of the energy that you were using. And then you can say you have for example, a 5% improvement, or you are working only at 95% of the previous. So it's a bit different how you want to calculate it or how you want to represent it. But that would be one way to do it. If there is a certificate of participation in this webinar, no, there is not, unfortunately. So that is not available. How can we trace CO2 reduction by HIG-FEM? Well, you can do that year by year. So if you have completed your HIG-FEM, for example, 2021, and then the tool, the HIG-FEM, calculates automatically the Scope 1 and Scope 2 emissions. And then you complete your HIG-FEM 2022, and then you can then compare the results that are calculated for this year. Or you take older years as well. That's possible. Or you play around with the tool, that you can do as well. And you have a look at, if I can reduce my gas consumption this much, what would be the difference in the carbon emissions. So before you post your module, obviously, when you are still working on your self-assessment, you could play around with it and change the consumption values, and then you would also see how your carbon emissions would change. Yes, and there is also one question regarding carbon footprint reduction. There is 5 to 10 years plan. This sounds fine, but one thing needs some more clarity. It is about the absolute reduction line for carbon footprint. I mean, how much reduction would be considered reasonably reduced? And there are also rules from the Science-Based Target Initiative on how much you need to reduce in absolute numbers. So there is like a linear, calculation tool that you can have based on how many years you are planning for, and then you must set at least according to this reduction plan. Can we take a training on how to measure greenhouse gas? Because most of the persons dealing with data don't know the factors. Yes, absolutely. So please contact us separately. But there is no visual dashboard on HIG-FEM to see the carbon dioxide reduction. No, you cannot see the reduction as such, but you can see the calculated carbon emission for scope 1 and 2. So you have to take like a screenshot, and then you can change your consumption values, and then you can compare. So there is not a tool within the HIG-FEM where you can get the reductions calculated for you. Yes. Is there any possibility to get some Excel sheets to calculate greenhouse gas emissions by simply entering the usage units of fuel, etc.? There are such tools actually available online. Also on the Greenhouse Gas Protocol website, there are some tools available. And of course, we could support you with this, but this would be then within a project together. All right, thank you. We are receiving an email address here. Thanks. How effective are policies being implemented in garments to reduce greenhouse gas emissions if other sectors do not take action? This is a really, really good question. And this is a bit, you can say it's like the chicken and egg question, who should start? But it is also, you know, is my neighbor doing something? Why should I be doing it if my neighbor is not doing it? And this is one of the big problems, I believe, that we have generally worldwide, because everyone thinks like that. And so you think, yeah, my contribution is so small. If I change something, it will not really matter. And he and she and they don't do anything. So why should I? But that's exactly the problem. And we need to stop thinking like that, in my view, and just seek to take action. And this is true also for the garment sector. And I think the garment sector is really, let's say, starting, and many brands are doing quite a lot to reduce their carbon footprint. Many suppliers are also working really hard. We see that with the HIG-FEM, for example. And we just need to continue and try to take our own responsibility. So if we are responsible for a certain small portion of the total outputs, then we take responsibility at least for that portion. So that would be my response to that. But it's a topic where you could probably spend several days discussing, and so it has been as well. Okay, thank you. Yes. How can I determine the boundary of the company if there was a lot of strategic changes in the company over the years of the target? Yes, this is very, very difficult. And if you have, for example, let's say you are a brand and you have several entities, and then now one office closes down and one store closes down, or you open up new offices, you add new suppliers, or also as a supplier, you may be increasing your production, you may be building one more factory, etc. And it's really difficult, and you need to think it through very well. How do I want to calculate for this? You need to take that into account, of course, because your consumption values will change, your greenhouse gas emissions will change due to these changes. So it's a really good question and a very complex a topic to address. Here we have a really good comment also from one of our colleagues. And he says that, of course, you may change base year in some particular conditions according to science-based target. For example, if your company started to increase the production capacity, you can change the base year. But the point is, if you are setting an absolute target, it should be decreased in target timeline. So please do not forget that if you are setting an intensity target, at the same time, you should claim an absolute target. So what our colleague here is saying, and Sophia mentioned that, if you set an intensity target, which might make sense because you then have a target that is perhaps linked to your actual production, you at the same time, you need to make sure that that intensity target allows for an absolute reduction. So that is really the big challenge with the Science-Based Target Initiative, that you do need to reduce your emissions in absolute numbers as well. Yeah, we have a question about that as well. If any textile manufacturing entity is increasing their production, then of course their emissions will increase as well. And this is what, as I said, this is the big challenge with the Science-Based Target Initiative. And that is why such big measures are really needed, and such big and bold actions are needed in order to be able to reduce your absolute consumption. All right. Yes, I think that was all at the moment. So thanks a lot for all your questions. And then I would say thank you so much for participating in today's webinar. We have also one slide about ourselves here. So why work with us? Well, we are really sustainability experts. We have a long experience in the sustainability area. We have been working in the textile sector for a long period of time, but also in many other sectors. So we have a good understanding also, for example, hard goods sectors. And we have we approach our projects with a holistic approach. So we take a lot of different factors into account, the size of the company, the country, the perspective of management, the perspective of workers, and of course also because we cover both the strategic area, let's say at brand level or at factory company level, management level, but also we have a really deep understanding of manufacturing. We spend many hours, many days every year in the factories, and we have a lot of both environmental and social experts who are working in the factories on a daily basis. So this is our holistic approach, and we have a wide range of services in the field of sustainability, including climate services, but as I mentioned also auditing services both for environment and for social. HIG-FEM was mentioned already in the questions. We have more than 25 HIG-FEM verifiers worldwide, and here you see some of our colleagues. And with that, I would like to thank you so much for joining us today. It has been a pleasure to spend some time with you, and thanks also for all the great questions you were asking. And with that, I wish you a nice afternoon and a nice rest of your day. Bye-bye.